Okay, so we're going to talk about the idea of definite integration using definite integrals. So we start off um, with an assumption that if f is continuous on the interval, which is closed interval a to b, um, and f of x is the derivative of some other function, um, which that we normally use as like the derivative of capital F equals f of x. So capital F is kind of a step up the line. So it's kind of like how you had y going to y prime. Um, if you have f sort of, if you go down, you have f prime, but if you go up, that means that's capital F. So it's just basically, this is derivative, this is integration. So if we have this, then they bounded by a to b, it follows this form. So your last term goes up at the top, or so your wider interval goes up. Your left endpoint goes on the bottom, so that's a. And you use your function dx. So what we do with these numbers is this. The integral, as I said before, is capital F. Well, what you do is you do capital F of b minus capital F of a. And that represents our definite integral. In a sense, what this represents is the area under the curve of the entire graph all the way up until you get to this x-coordinate b. And then we're subtracting, or we're cutting off everything below a certain point. So we're basically finding, so imagine kind of, let's say we have a graph. So this is b, and this is a. Okay, well, right here, big F of b represents everything, all the area, all the way up until b. And then if we cut away capital F of a, we're just left with the area between the two of them. So that's the way that this works. So again, this graph just kind of illustrates the same thing. You've got all this right here represents area under the curve of a graph between 2 points A and B. And so that's what you'll see this listed as. Now, so let's look at an example problem, okay? Well, how do I go, or sort of an example. I'm not going to go everywhere. But this is a definite integral worked all the way out. And so what happens is I have the graph, and so we're saying, what about x squared plus 1? So I'm going to graph x squared plus 1. Here, 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 here. Okay, something like this. And it's giving me my endpoints. It's saying 0 and 2. So first of all, this is x squared plus 1. My endpoints are 0 and 2. So I start at 0, and I go to 2. So everything under the curve there. So this is what my integral is, my definite integral is finding, based on the information that it's provided. So how do I figure out what this is? Well, the first thing that you do is you take the integral of x squared plus 1, which the integral of x squared plus 1 is simply this. X squared plus x. Now, in some cases, now it could be any sort of number added on here at the end. And what you're going to see is that the derivative of these actually ends up canceling out. So this is what your normal derivative is. This is like your c value. If you look down, here we're subtracting a c, here we're subtracting a negative c, right? It doesn't, these always cancel. The c's actually don't matter. So you don't even have to worry about doing the plus c's at all, because it doesn't affect anything, because you're taking the same c away from itself. So they actually end up going away just like this. So in a sense, you can find this. It's actually just a little bit easier than you would if you had a definite integral.